everyone, today we'll be going over how to build a large language model from scratch with no GPU, all under 15 minutes, and without any further hesitation, let's get started. Hey everyone, today we'll be going over how to build our large language model with no GPU. So overall, what I want to show you folks is something I have been working on for the past few weeks, largely just building out this comprehensive large language model, taking everything I've learned from my 2 master's degrees, and then be able to apply it in the context of natural language processing. So overall, when it comes to AI model development, I've broken it down into these comprehensive steps, and then when applying it in the context of large language models and natural language processing, it really comes down to how we are going to be extracting a certain amount of data and then also model architecture, and then going through the following steps of training, validation, and testing and backtesting for a following model as well. And then also have the reinforcement learning human feedback loop as well to understand how well a model is doing and if we can understand how it is going to perform really. So first thing in particular, when setting up inside of the Jupyter Notebook, I already established the libraries are already right here. Now a big majority of AI model development in the present definition is revolving around data feature engineering and exactly how well that data is cleansed, parsed as well. Now, given the fact that we are dealing with a model architecture called a transformer, going down over here to check, and the transformer model architecture typically has these following components that are over here: multi-head attention for feed network, and then also the transformer block. And overall, I combine them all together to have the full transformer model that have encoders and decoders, and then also hyperparameter tuning for our following model as well. I thoroughly documented this as well for everyone to go through step by step. So when you have the time or feel like you're able to, feel like you want to play around with this, I have different variations of these notebooks at the same time throughout my progress, such as when I was first breaking it down initially in the Mach 1, and then started to build up. The reason why I was doing this on a CPU and not a GPU, one, keeping in mind of everyone's hardware constraints, and also I'm taking in my current GPU right now for an extended warranty with NVIDIA, so hopefully they get back and able to replace what's been going on. But overall right now, the following breakdown that I have noticed in particular, and one thing I did manage to utilize for the CPU, was really coming down into batch processing. So the present cases of large language models rely on this comprehensive data set that is backed by a nonprofit called Common Crawl. So if I can just pull this up right over here, they retrieve WARC files, where WARC are basically web archive formatted files, where they're just basically all the scan type of web pages across the internet, which is a lot of data that is able to be tokenized, where we're able to actually have a value that we have. If I were to give an example, for instance, so we notice in particular, for instance, in this one wet file that we have. So wet is another component for the web archive. It's a web abstracted text where it is basically the web, it's basically the plain text inside of the WARC files, and we have to find a way where we can actually clean and pre-process it, and that can be done with a series of Python scripts I'm also going to include inside of the repository. But what we have in particular is that we have tokens where, say for instance, we have a sequence that we have over here. What we need to do is actually take out every single word that we have and make them into comprehensive tokens. And then we have token IDs, where these IDs are going to be coming off from a vocabulary that has been made. Let me see if I can pull it up in the other one. So the million words is something that worked for me. Let me just pull this up. This entire JSON file that we have is going to have a specific word, and this is already formatted in pad, unc, and then following spaces as well, but they have a corresponding number associated with each of the word that we have. And in particular, each of the following words that are separated with a given space as well, that have been cleaned and processed, they match up with the vocabulary. Here we go. Here's a tokenized wet one and more. Apologies on that. So overall, they basically have a sequence of words that we already have that pair up with the number and then also correspond within a given wet file that we have. Now, if we were to extract solely on the WARC files, we would it will be very long because one, the work files are raw components of the data, and the wet is considered the plain text that we have already made. And you have to go through the various steps to be able to actually download and pre-process. And I have more Python scripts that actually go in depth to actually retrieve and download said files as well. According, like in particular, if we were to go over to Common Crawl, we can see over the latest crawl that we have that they have. So over here you can get the work path files that you wouldn't necessarily download, and also WAT, which is the web, which is more the metadata. It's like a wet file, but has more of the metadata inside of it. And yeah, this is the acronym that they basically just put it up: Web Archive Transformation, that contains more of the metadata, the images, and other corresponding parts that we have for a web page. So that way it's more organized. But I was creating my large language model, and this one is currently training right now. I was focusing on the wet files in the plain text of English, so that way I can be able to tokenize every single word that we have, and then we have a comprehensive vocabulary and have 20 wet files that we will use for our large language model, just to be able to give something simple, and also keep in mind of computational restraints as well. And I also had this script as well that was made inside of the Jupyter Notebook, and also thoroughly documented as well, because when dealing with hardware constraints, batch processing is a popularized technique. I also tried bucketing, but a big problem that I did notice is that my data set in particular, if I were to go over to another transformer model, over here, this is a local host, going down, it would generate a lot of these outliers. I also have backtesting results as well if you want to take a look at that. That's not it. It should be the... here we go. So I was getting a big portion of the predicted text to be UNC, actually, which is more of the separator, or it is the default token whenever there's something that is not already added inside of the vocabulary, that the model would eventually predict what would be the next word in that case. So that is why initially I went up from, if I were to, for a second, where I went up to 50,000, 100,000, 400,000 to 1 million vocabulary words. And now we're going over the details for our following steps. Here we have the following over here. I'm just going to break it down. We have data feature engineering first, where we have used Common Crawl datasets, and we have used 20 wet files in this case because web archive files are very big in terms of data. They contain about terabytes of data, and we use web files specifically because they are the plain text, and we also filter out because work files are web pages that are all on an international basis, and it's more it's more computationally efficient if we were to focus on the language, on one specific language for a model to be able to perform better. And then we also need to follow the processing of cleaning, tokenization, and then vocabulary building as well. So that way we can match up the numbers and tokens that we have made between our files, and then build a comprehensive vocabulary list as shown before. Then we add token IDs to our tokenized text from our wet files. And then in our data feature engineering part, we implement batch processing, which make it computationally less expensive, so we are able to run it on our CPU. And then one would need to be able to split their entire data set into the following components: 80, 10, 10, or 70, 20, 10 for training, testing, and validation. Excuse me. Then we have the model architecture. In this case, we're using a transformer model architecture, hence the name ChatGPT, general purpose transformer, the T standing for transformer, and we have to optimize it on our CPU. So the transformer contains these three components: the self-attention layer, forward feed, and then the transformer block, which include encoders and decoders. Again, it's all down here in the details. Here we go, right over here. So again, I documented everything step by step, and also in further details as well for everyone else to be able to play around with it. So let me just go up. And then we also have training and validation, which happen to be in the same block as well. And then after our model has been trained and achieved validation as well in those following steps, again, it's all in one block. I have made 3 different components after training. As you can see, we have a model train that's right now. Well, 2 components here. to be able to save the model and then be able to recall it and load it as well with those following parameters. Make sure as well you look back here and go back to step 2 to make sure and see the following parameters of how many components are required. Like we have the embedded, we have the number of layers, and also our vocabulary size, because this needs to be changed to 1 million, not 50,000 like it worked before. There we go. And then do the same thing here. Make sure that all the numbers already match up between step 2. Then afterwards, we would backtest as well. And we are just backtesting on the last component we have, the 10, so that way we know exactly how well Mars is performing. Now now the 4 tests I actually put in were the perplexity score, blue score, and rogue score. And there's another one called the diversity score. And then we would identify improvements based on backtesting results. And then the next part is reinforcement learning human feedback loop, where basically what it is, it's just an interface that I have made in Jupyter Notebooks, so that way we know exactly how well the model in of itself is interacting based on a plain text. Like we have an input and then we have our desired output as well. So I also did that in other iterations at the same time, so we know exactly how well it's actually performing if it's predicting the next token. Here I had this error before where it would predict pad and unk because of the batch processing. However, there was another script I made to be able to get feedback on that located in the data feature engineering section over here. So this entire script is made to be able to signal how many of the unk and pads we have for each of the sequence, for instance, that our data is being sampled over here in this case. And then we go through the train, test, and validate, same thing all together, and then we finally convert our PyTorch model to Onyx, so that way we can output it, because Onyx is the format that is all for universal models that can be implemented on multiple platforms. And then we can choose a backend of our choice, such as Microsoft Azure or Firebase or a Google Cloud as well, depending on exactly what you want to do and how you, where specifically you want to put your model for a person to be able to interface and stuff, and have continuous integration and continuous deployment as well. So yes, this is just an overview for an intensive project I've been working on for the past few weeks. Thank you again for taking time to watch this. And yes, hope this helps you in your journeys for what you are looking for. And best of luck to you. Thank you. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. If you have any other questions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.